As you work with data, you often find yourself dealing with lots of files, or really big files, or in some cases, lots of really big files. In these scenarios, compression and archiving are really useful for storing and sharing those files efficiently. In this video, we'll look at several compression and archiving related commands. They include zip and unzip, gzip and gunzip, bzip2 and bunzip2, and tar. If you want to follow along using the example files and folders in this video, the link to download those is pinned in a comment. Before we start working with the commands, let's first differentiate between compression and archiving. Compression is a way to make a file smaller but retain all of its contents. It saves you space. So, for example, compressing a 100 megabyte file might make it 30 megabytes in size, but all of the information in the file is still there and can be recovered when you need it by uncompressing it. In contrast, archiving has no effect on the size of a file. Instead, it reduces the number of files. Say you have 100 files. You can save them individually, or you can archive them into a single file. Think of this as having 100 small objects that you pack into a single box to store. Then, if you need them, you can simply unpack them. In my working directory, I have 12 text files and one folder named 12D data that stores 4 additional files. The first commands we'll deal with are zip and the related unzip. The zip command has both compression and archive capabilities. It requires you give it at least 2 items. First, the name of the new zipped file you're going to create. I'm calling it zipfile.zip. And then, one or more items that will get compressed and packed into that one file. Wildcards or globs are accepted here, so I'm using the star to represent everything in this folder. By default, the zip command prints a status for each item it's working on. After it's run, my directory now contains the zip archive, in addition to all of the original files and folders. Next, I'm going to create a new directory named zip results, move the new zipfile.zip into that directory, and then cd into the new zip results folder. Once there, I'll list just to double check the file is there. Now, what if I want to work with the data stored in this file? I'd need to first unzip it. Conveniently, the command is unzip. Again, we see some information printed regarding the status of the command for each item. Something to note here. Listing the uncompressed contents gives results that look similar to our original folder. However, there's something missing. If we check the contents of the 12D data folder, there's nothing in there. If we go back to the status information that was printed when we ran the zip command, we see that the folder itself was zipped, but not its contents. Let's return to our original folder with cd ... We'll remove the new zip results directory we created, along with all its contents, by using the -r argument of the rm command and start over again with our original set of files. This time, I'll zip the contents of this folder again, but I'm going to include the -r or recursive argument to tell zip to include folders and all of their contents. Notice this time those files inside the 12D data folder are also included, and we'd see them if we uncompress this new archive elsewhere. Let's move on now to a second form of compression, gzip, and the related command gunzip or gunzip. We'll apply gzip to the same original set of files we used for zip. Unlike the zip command, gzip doesn't require that you provide a name for the output file. So, I'll type gzip, use the -r or recursive argument, which works the same here as in the zip command, then give a list of all the items I want to compress. I'm being more explicit here about exactly what I want gzip to compress, instead of just using the star like I did before for the zip command. This is because now the folder contains zipfile.zip that we just created, and I don't want that included. Listing the results, we can see that gzip works a little differently than zip. This is because gzip provides compression only. It doesn't archive anything. So, each individual file is compressed, and the .gz extension is added, but we still have the same number of files we had before. Pay close attention to what happened here in comparison to what happened with the zip command. The zip command that we ran previously took each of the files and folders, compressed them, and packed them into a single zip file that was added to the directory. The original files remained as they were. With the gzip command, the original files were replaced with their gzip compressed version. If you prefer to keep the original files when running gzip, some versions offer the -k or keep argument. gunzip works just like unzip. Here, I'm uncompressing each of the gzipped files in my current directory and also those in the 12D data folder, which takes us back to the original files. So, if gzip doesn't archive files, how do we get something similar to the zip archive when using gzip compression? That's where the tar command comes in. Tar's primary function is to archive files. I've listed my directory contents just to remember what we're working with here. The tar command functions to both create an archive and extract or unpack files from an archive. Because we want to create a new archive, we'll use the -c or create argument. We also need to give it the name of the new archive file everything will be stored in. The -f argument does that, and we'll call it tarfiles.tar. Listing the resulting content shows the new tar file, which is sometimes referred to as a tarball. This file alone is an archive only. It contains all of the individual files, but they aren't compressed in any way. The -z argument available in the tar command lets you add gzip compression all in one step, and accordingly, we'll indicate this in the new file name by adding the .gz extension. If we list the contents one more time and do it in long format, we can see the two tarballs and compare their sizes, with the one with gzip compression quite a bit smaller than the one that's not compressed. Notice too that the gzipped archive is smaller than the zipped archive, but both store the same information. This is one advantage of gzip. It's often more efficient both in terms of file size and compression speed. The last set of commands is bzip2 and bunzip2. bzip2 is very similar to gzip, so much so that there's really no need to go through additional examples. You can just replace gzip with bzip2 and gunzip with bunzip2. Within tar, the -j argument is the bzip2 equivalent to -z. bzip2 might produce smaller file sizes than gzip, but that efficiency may come with slightly longer runtimes to do the compression. One more point about tar that will apply to other commands too. Sometimes multiple arguments will be listed together. For example, tar-czf is equivalent to tar-c-z-f. The order might matter though. For example, the -f argument expects you to specify a file name. So, tar-zcf and tar-czf would both work, but tar-zfc wouldn't, since you need to have a file name directly after the -f argument. One additional argument that can be useful with all of the unzip commands is -t. It provides a test for the integrity of the compressed files. Say you zip a set of files and then want to delete the original files to save space. It's a good idea to run unzip-t on the zipped files before you delete the original files to make sure the compressed files are all intact and can be recovered later. Finally, given the different compression options presented here, there's the question of which one to use. Overall, zip is probably the most widely used, but within bioinformatics you'll see gzip much more often. This is probably due to the greater efficiency of gzip and the fact that gzip was developed for Unix-type operating systems, which are widely used in the field. Assuming you're on a Unix system, I generally suggest sticking with gzip, and tar as needed, unless you have specific reason to use something else. But in practice, any of the options will work in most scenarios. While this video covered how to uncompress files, there are other approaches that are often more efficient. Check out the video on working with compressed files to see these.